Today we're going to look at geometric series. For the warm-up, given the series, fill in the information. So the first one, arithmetic or geometric, you should be able to tell by now this is geometric. So it has a common ratio. To find the common ratio, take any number, divide by the one before it, so it's negative 1/3. For this one right here, this one is arithmetic. The common difference, just take a number, subtract from the one before, so here common difference is 2. Can you write the summation notation? All right, so for this one, make our sigma. We start at the first term there, 1, 2, 3, 4, 5 terms here. And then here our first term is negative 27. The ratio is negative 1/3. If we start at the first term, this is to the n minus 1 power. Find the sum. You add up all of these together. So if I did that correctly, I get negative 20 and 1/3. Okay, write the next one in summation notation, arithmetic, okay? So for this one, we have, looks like 7 terms. We know the slope is adding 2 every time. The y-intercept go backwards 2, so negative 8. Find the sum using the formula for, Gauss's formula for finding the first 7 terms. That would be the first term plus the 7th term times the number of terms, in this case 7, divided by 2. First term is negative 6, 7th term is 6, times 7 divided by 2. And negative 6 plus 6 is 0, so the sum of this whole thing is 0. If you add them together, it is 0. It's not a great 0. Okay, to review, a sequence is an ordered list of numbers. A series is the indicated sum of a list. So I might want the sum of 7 things, the sum of 5 things, or so on. That's indicated. Sum of your sequence. A sequence. To find the sum of an arithmetic series, this is what we did yesterday, Gauss's formula. You can use this formula, first term plus last term times the number of terms divided by 2. In class, we do a convergent divergent geometric activity on Desmos to see what does it mean to be convergent and divergent. Let's summarize here. In a geometric sequence, each term is found by multiplying the previous term by a ratio. We know the explicit formula is exponential, first term, times the ratio to the n minus 1 power. And there's this formula that they go over in the investigation, and that is this. It's the first term times 1 minus the ratio to the nth power over 1 minus the ratio. It goes over the definition of convergent when it approaches a limit. In other words, it has a sum. Versus divergent, which does not approach a limit, keeps going on forever. It does not have a sum. So it doesn't approach a limit. And it doesn't have a sum. Doesn't add to anything. Keeps going forever. Okay. So let's do some problems. This is a partial sum. So if we're not adding up everything, a partial sum of a geometric series, to find the sum, you take the first term times 1 minus the ratio to the nth power or over 1 minus the ratio. So let's do some examples. Find the sum of the first 4 terms of this list of numbers, this sequence. The first term is 10. The ratio, if you take any number, divide by the one before, we get a 3. The number of terms, let's just add up the first, let's make it easy, the first 3 terms. All right, how to write the sigma notation. Start at the first term, go to the third term. The first term is 10. It's being multiplied by 3 every time to the n minus 1 power. Let's plug into our formula, our new formula, whoops. And that would be first term, 10, times 1 minus the ratio to the third power over 1 minus the ratio. When I type that in, here's what I do. I use a lot of like parentheses and stuff. Pull this up. Let me clear this out for us. Okay, so I would do the top first. 1 minus 3 to the third power. I would do that first. Divided by, I would do the bottom of the fraction, 1 minus 3 in parentheses, and then I would multiply that by 10, by that first term. So the sum of the first three numbers is 130. It's pretty easy to see, so I'm going to write that down, the sum. Right, again, we could have just added up the first three terms, and you could see that 90 plus 10 is 100 plus 30 is 130. So there it is. There's the formula. There's the answer. Example 2. Calculate the sum. Okay, so one zombie enters the school. After 1 hour, there are now 3 zombies in the school. After 2 hours, there are 9 zombies, etc. Calculate the sum after 7 hours. The number of zombies after 7 hours using the partial sums formula. Okay, so to do that, we have 7 hours here. Okay, so here's the explicit formula. After 1 hour, there are 3 zombies. Okay, so we are starting at the first term, so I will do n equals 1 to 7. Here's our equation. Okay, so then to find, using the formula, we need the first term, which is 1 zombie, times 1 minus the ratio to the number of hours, 7 hours, over 1 minus the ratio. Again, typing it in, here's how I would do it. I would do the top part first. 1 minus 3 to the 7th. I would hit enter. Divide by the bottom in parentheses, 1 minus 3. And then I would multiply by the number of starting zombies, that is 1. So after 7 hours, there are 1,093 zombies. Not 93 or 73, I forget. 93. There you have it.